Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 at midnight Eastern Time, and 3 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Welcome back, Jeff.
Thanks, it's good to be back. Tonight's project is coughing. It's bursts from space. We'll be back in 8.3 seconds. Okay, fast radio bursts are massive bursts of energy we see from across half the universe. We call them fast radio bursts because that's what we see. A brief millisecond burst of energy in radio waves. What are they? We don't know, but every burst we find tells us a little more about what's happening. We need to find these bursts.
That is a direct quote from the site, and let me go ahead and share that with you right now. And I'm going to take the lead on this tonight. Give Jeff's voice a break. You know, we actually noticed this part up here that says bursts from space in the Explore project. That changed from like yesterday. However, this is a Zooniverse project. So like a lot of the projects, it does have, oh, hey, Scott.
Hey, Scott.
Oh,
thanks.
That's nice.
Yep. And I cough for a couple weeks after every time. So you're just going to hear me cough.
Yeah.
That's all.
So they've put the various navigational tabs in this. So just so you know, but I'm going to get back to that because I want to kind of cover the whole thing. So it's a little bit different up here, but the rest seems to be just the same. And they've made a note. They keep adding new sets, and that basically happens once a week. But I'll talk about that briefly as well. Hunt mysterious bursts from space, and they really don't know what they are.
Hello.
Oh, welcome.
Yeah.
We're not even going to try. Abhishek Pandey, welcome and thank you for joining us.
Yep.
All right, so I'm going to go down the page, and here is kind of what you're going to be looking for in this particular project. Oh, somebody's talking, and you can join in. Now, it looks like it's complete. Well, 99% complete, but remember, they add stuff every week. So lots of people working on it.
Yeah, the detectors are still generating data, so they've still got data for people to use.
Right, every week. And this is what Jeff read right here, this part. So we're going to try and figure out what the heck these things are. And like a lot of these projects, many people will be looking them over. Oh, hello.
You got his name right.
Oh, good. Thank you. Oh, we got more? Hi, Cliff.
Hey, Cliff.
Oh, you're not late at all. You're just in time. So, yeah, here they go. They say on most weeks, Thursday around 2 p.m. UTC, they'll bring new data from the telescopes. You might be the first person to find a new fast radio burst. And keep in mind, this is a radio telescope, so they look kind of boring. Well, it's kind of interesting to me, but they're not doing much. They sort of just sit there and gather data.
And it looks like a water heater, a solar water heater.
Yeah, it does. And so I know somewhere else they talk about how many people will be looking at each of these images, and they are basically, again, trying to kind of train the computers how to do this too. This one's CHIME, Radio Telescope in Canada.
Yeah, and this is going to be another signal versus noise.
Yeah, that's a good way to put it. So they do have some of these external links: the CHIME Telescope, Dominion Radio Observatory, National Research Council Canada, CHIME Public Discoveries, and it's a basic Zooniverse page. So let me go back up, and we're going to go ahead. Oh,
hey, Don.
Hi, Don. Welcome. Yeah, we're glad Jeff's back. All right. So they have the about, just like always, and they call these things Furbies. Fast radio bursts. So you can read more about this, and we like to encourage you to do that, but we will cover a few things in here. So again, they don't know what they are. They could be hypermagnetized neutron stars collapsing into black holes, sparks from cosmic strings, or maybe something else. And here's the thing: every observation helps.
Interesting thing about neutron stars collapsing into black holes, it might mean that as a star collapses, it might have a brief period as a neutron star.
Okay.
I mean, that's a possibility, is either that or a neutron star gets whacked by something big enough that it flips it over the edge from being a neutron star to a black hole.
Mm.
But yeah, that to me is the most interesting possibility.
So if you want to participate in this project, check out the things at this time on Thursday or on Friday. They'll have new material, most likely. All right. So, here we go. They see them as one-off events. And the thing that got me is that they can see them from half a universe away, which is weird because we don't even know how big the universe is.
Well, I think they mean observable universe.
Okay, I see.
So 13 billion light year or 13 billion light years
or whatever the radio telescope can pick up.
Yeah.
So there may be several types. And what else? Oh, this is kind of a funny video because it's pretty short, but they're like, ooh, it's in action. However, the telescope itself doesn't really move. But I like the pretty picture of the night sky. So
good action shot of that telescope.
Yeah, 16 seconds. It's worth looking at. All right. So let's see. Okay, it comes from the Chimes Telescope. We kind of covered that in British Columbia, Canada. And like I said, I think you should probably check this out. It's always great, even if you don't do a lot of the project or any of it. They've got wonderful information every single time with these projects. Okay, and just so you know, this thing won't retract until you hit one of the segments, or you take it back up. It's like a drop-down menu.
Talk about the team.
Oh, right, yeah, I forgot. Whoops. See, I gotta retract it. So the team, I didn't really look at this before. Thanks, Jeff, for reminding me. Mike Walmsley, Brian Geisner, Chris Lina, and so on. It's a pretty big team.
No pictures this time. A lot of these have pictures, but I guess.
Yeah. But it's kind of cool because if you like that sort of thing, you want to get in touch with them and chat with them. They do provide more information about doing that. And there's of course there's the usual what do you call it? It's a forum. It's a forum right here in the project. All right, and then they have frequently asked questions. How do I learn to classify? This one's actually pretty good. I would say this is one of the easiest ones that I've ever seen, but we'll demonstrate that shortly. How can I learn to classify? Yeah,
I disagree, but we'll get to that part.
All right. How do I know if I'm right? And again, they're gonna have lots of people look at each image. What if I submit a wrong answer? Don't worry.
Basically, you get enough people on it, and the few outliers.
Yeah, if they get too many conflicting, reports on a particular image, that tells them they need to look at it directly. So, yeah, I'm only seeing training data. Why?
Because they only have about 1,000 images a week. So, if you do a lot of classifications, you'll run out of them.
Oh, all right. So anyway, there's a lot more in here. I would definitely recommend reading this if you would like to participate in this project. And they talk about why do they look like this, and it's just kind of this vertical thing. All the rest, this is either noise or human generated. So the horizontal lines in here, that's kind of just stuff you can ignore, basically.
If you notice, it's a single frequency over a long time.
Oh,
so
yeah,
that's
right
human
there.
generated. Yeah.
Yeah.
The burst that they're looking for is across a range of frequencies over a very short time.
Yeah, it's a very, very short time. They're thin because they're quick, only lasting a few milliseconds. Again, they don't know why. But that's what you're looking for. You're looking for an image that has a vertical kind of spike like that. So let's see. What's next here? Classify. And that's where you find the project. As usual, they have this tutorial. Notice there's only 3 pips.
Yeah.
So
I'm not thrilled with the tutorial of this one.
Well, there's more in the field guide too. So there's information down here. Help us hunt mysterious bursts from space. We've recorded thousands of radio pulses. We need you to tell us which are from space and which are human generated. Cell phones, airplanes, stuff like that.
Hey, David.
Hi, Dave.
Have we determined the most distant FRBs from the early
Ooh,
universe?
I don't know.
Yeah, they don't mention that here. So,
well, and again, there's all kinds of links that take you to other information on other sites. I would say that's a good place to start.
And they do have a forum so that you can ask that at the forum.
Yeah,
ask them there.
Yeah, that's a really good place to go. All right, so we will go ahead and continue. And here we have, again, this is this really thin vertical in these images. Here's some data. The faint verticalish stripe is a burst from space. They're often much fainter. So think of this and smaller. But they do come in many different frequencies, only for a short time. All right, so stuff like this, and sometimes they have this curve like this, even though it's, verticalish, it's still not one of these bursts. Here's some human noise from us, not space. Anything but a smooth and roughly vertical line is probably humans. Curvy, weird patterns, not what you're looking for. So you're trying to separate out the two. All right. So I'm going to go ahead and talk to you about this field guide, because when we first looked at this, it seemed kind of sparse. So here's the field guide. It pops up from the side, just like all of them. And you've got just a few things to look at, but they are pretty informative. These bursts are tall and thin, and they have several examples here. They might have a slight curve, but not a deep curve like this one in the example already. Yep, here's that one again from the beginning. And even this is one of these bursts. They're kind of faint. I would say this is one of them. Here too. Look at that. That's like a little bit not as smooth as you think they were talking about, but that is apparently one of these bursts as well. Ignore any horizontal lines or horizontal gaps. All right, back to human signals. Noise from humans is anything that doesn't look like the burst from space.
David says, if we found FRBs from the dawn of time, it presupposes stars formed early and died way before our star was born. Assumptions, planetary systems may have been formed after that as well. Well, we kind of assume that stars have died before our star, because otherwise we wouldn't have the heavier elements to make our solar system.
Yes.
So now how much of that happened is kind of, I don't know.
So that's even more evidence to me. The Furbies are even more evidence. So
yeah. And then Chris Linnott from the team is one of the presenters on BBC Sky at Night.
Oh, cool.
And worked with Sir Patrick Moore, which
all right.
The Cardwell catalog is oh, okay.
Huh.
Patrick Cardwell Moore. Oh, okay. Huh.
Very cool. Thanks, Cliff.
And David, that being the case, is it possible life forms existed on planets at an early age? And could there be any level of advancement now? Drawing a long bite, I know. Well, in the earliest stars, doubt it. Could be wrong, but doubt it simply because they pretty much had hydrogen and helium to work with. And it's when the earliest stars blew up, they created heavier elements. And then the second generation, maybe. And I don't know how many generations we're on now for stars.
I have no idea either.
Yeah. Recent measurements show the average FRB releases as much energy in a millisecond as the sun puts out in 3 days.
Oh,
that's a lot of energy.
I didn't know that. Okay, thanks, Dave. Hey,
okay.
See, welcome.
Yeah, we still don't know.
Yep.
Even with the repeater FRB, what they are. Yep.
Yeah, they emphasize that a lot in this project, that they just don't know what the heck these are, whether they're one-offs or whether they see them over and over again.
And they do see some over and over and again, they've said.
Yes.
But
magnetars. Ooh, that's a nice theory. Yeah. All right. Thanks so much for your comments, everyone. Really, really appreciate that. I always learn something when you chime in. All right, so they're saying that yeah, a lot of this stuff, human, bright, complicated. That sounds about right. These things here, yeah, just kind of messy, not really a burst from space.
David says they could be from hypermagnetized neutron stars.
Yeah.
Neutron stars collapsing into black holes, sparks from cosmic strings, or maybe something else entirely.
Right.
Yeah. They're kind of getting away from cosmic string theory.
Oh.
They haven't disproven it, but everyone's looking at other things now. I've seen some articles on physicists who do cosmic string theory, and they're talking about it being a dead-end career choice.
Okay.
Doesn't mean they're wrong. It's just no one's doing it now.
So while there can be some repeating bursts, stuff like this, it's not a nice narrow band. These are very, very short. So this is much longer than normal. So that is still probably human generated noise.
Yep. And David says, my feeling is two neutron stars colliding and forming a black hole. Makes more sense. Gravity waves produced, yeah.
Yeah.
Yeah, it all depends on how often this happens. I mean, how often well, I guess if you're looking in a chunk of sky, that's a huge amount of territory. So maybe it doesn't have to happen very often for us to see these somewhat frequently.
Well, and I think about things like, it's called LiDAR, right? And they were looking for stuff for a very long time, and only finally in recent years got the little chirp. So these bursts seem like they're happening much more frequently than, say, a gravity wave from two black holes colliding. So yeah, right. I don't know. We'll see.
Well, they're easier to spot than gravity waves. Gravity waves are hard to detect.
Okay. All right. So you might get something that has nothing. They're blank, no visible signal. And they do have a choice to pick nothing here. In fact, it's that one. We'll look at that in a second.
Now, unfortunately, neither the field guide nor the tutorial tell you actually what to do and how to look at these. They just give you some examples and, say, y'all be careful now here.
And see, even this one here, I kind of see a thin line.
But it might just be random.
Yeah, I might pick that as one of the bursts, in fact, instead of there's nothing here.
That's one of the ones that's the type of thing that we've disagreed with sometimes on these.
Oh, and they do talk about the range. So definitely take a look at this. There's one more. Hope it's complicated. Yeah, some of these can be really, really messy. Oh, we got something here, but let's see. Well, it could be both. It could be humans and signals from these bursts. Yeah, look at this. Even that looks like a burst to me, that really long, skinny one. But there's lots of other stuff in here. I don't know. I would just classify it as a burst, I think. But again, many people will be looking at each of these images, and they will get a chance to understand what they are.
Yeah, and I haven't seen one that doesn't have human activity in it. But
yeah.
Okay, Scott says these pictures just look like static on an old TV to me.
Which is the cosmic background radiation. I love that. So anyway, yeah, see, to me this looks like it's got a burst in it, but then there's a lot of junk. It's true. Oh yeah, look at this. Human generated stuff, maybe a burst. That looks pretty thick to me though. And this one's just way too curvy. This one's a little bit more like the bursts. Some look like they're from space, but they repeat. And these, might be actual bursts that do repeat. And they might be coming from a pulsar. Mm-hmm. So, like I said, all these links, all this information, definitely take a good look for yourself and see what you can see.
Mm-hmm. And David says, maybe there are really several types of FRBs. Yep. Maybe they all repeat, but some just repeat much less often.
That makes sense, yeah.
Yep.
Right. Like a lot of things, comets that come back only very rarely, like Halley's is what? Mm-hmm. Already 76 years, but it does come back. Yep. All right, so let's see. They say you might find something totally fascinating or unexpected, like this super strong repeating signal or this particularly unusual human signal or something that looks broken. And they've always got this talk. So you can consult with these people if you wish. Yeah, see, these to me look kind of wide. They kind of look like they last a lot longer than the bursts would.
And it's over a huge frequency range.
Yeah. But then, of course, you got this messy horizontal thing, which probably human generated.
Yep. And Chime needs help, guys. Chime records far more candidate bursts than the project scientists can look through.
Yes.
They need our help to sort through these candidate bursts. Yep.
And it's a pretty good project to do. It's not super complicated. That's it for the field guide. It's not super complicated. You don't have, all kinds of things to mark, and you don't have to train for this one, I would say. So let's run through a few of them. And Jeff and I did when we were, checking out this. And I would go, in this case, it's all human generated. I don't see anything that's vertical or burst.
Oh, show.
Oh, yes, right. We got a couple of options here, so you can look at them. And as typical, you can actually run them back and forth in this manner with this little play button.
Yeah.
But yeah, whichever way you prefer. There's lots of options.
I like the grainy view better than the fuzzy view.
Sometimes it can help. Yeah.
Okay, and AC repeating fast radio burst. Oh. That one.
That's probably date.
Yeah, originates from a magnetar.
Oh, they figured out where it's from.
Oh, actually,
E-star binary nature
and we're
communications.
losing the bottom of his.
No, it's all there.
No. Oh, yeah. Okay, you're right. From a magnetar, E-star binary. Oh, okay, nice.
Well, very cool. All right, so even when I'm looking at this other view, I still think it's all human generated. Oh, yep. Sorry.
David, every time I get sick, I cough for 2 or 3 weeks afterward. It just happens.
Yeah.
That's his reaction to being sick. All right. So in this case, all we have to do next is click on this done. You'll notice need some help with this task is always an option. So I'm going to go ahead and click on done. Let's see if we can find a burst. Yeah, no, I'm going to go with, this is still image. It almost looks like the same exact picture to me, but I'm going to go with still humans and done. So you just keep going through these. Ooh, maybe there's something in here. Nope.
Nope.
I'm going to go with
Human.
yeah,
because the
humans.
horizontals are human.
Yeah, that's probably the case.
And I think you should mark the human if you see human stuff in there, because they might be using that to train the algorithm to weed out human stuff.
Maybe, yeah. So I'm going with humans again. Let's see if we can get a good one. I'm not gonna travel through this too far, but oh, what's this? There's a little something vertical there.
But it doesn't look like what they were showing.
Yeah, I don't think it is either, but
it just randomly have some
blues
that are.
I think you're right.
Okay, AC says you need to explain dispersion to explain how you can determine it's an FRB and not a human RFI interference. Well, I think they basically talked about it briefly, and I kind of hit on it too, is that the human stuff is horizontal in this view because it's a single frequency that lasts for a long time, or changes over time, like these kind of sloping ones. But the FRB is vertical because it covers a range of frequencies over a very short period of time.
Boy, I found a bunch whenever we were practicing. I want to show you one.
Yeah. Well, before,
darn.
Well, before we just got a new batch. Yesterday.
Probably sorting a bunch. Boy, look at that thing. All right, so let's do a couple more, see if we can find one quick, and then we'll move on. No, I don't see one there either. Humans. Well, I'm sorry. It looks like we're not going to be able to show you one tonight. But like you see here, it's a pretty simple project. I think there are some things with, let's see, it's complicated. Yeah, it gives you a next. And there is another screen, but I'm not going to do that here because you want to classify them as accurately as you possibly can. All right, yeah, All right, let me go ahead and move on though. If they did get a new batch, we're probably going to have to sort through a lot of stuff.
Yep.
Before we see much of anything.
Yep. Okay. So Scott says, actually, it looks almost fun. Well, go for it.
Yeah, I would say it's something that can be kind of, if you're kind of tired and you're in neutral and you want to just do a bunch of them, yeah, give it a go.
Yeah.
It's not too bad a project. You don't have to learn a lot. It's not like some of them you can really sink your teeth into. It's very simple in a way, I think. But yeah, you'll see what it's like.
Yeah, you just have to be slightly better than a computer.
Yeah.
Okay, only one FRB has been detected to repeat in a regular way.
Oh.
It seems to pulse every 16.35 days.
Okay. All right.
Interesting.
See, we're just learning about it. If you've known something, that's cool. Thanks for sharing.
And AC high frequencies get to travel slower than lower frequencies due to the interactions with the electron density intervening between the FRB and us. The further away, the more dispersion.
Interesting.
Oh, okay, yeah, which could show that curve then over time.
Okay.
And it might be why all of the curves lean in one direction too.
Okay. Yeah. So far they've kind of looked the same.
Yeah. Cliff, if it keeps flashing only if a pulsar is pointed the right way, but I would think that a lot will not I'll spin at the same rate or wobble.
Mm-hmm.
Yeah, I mean, yeah, if it wobbles, then we'll only get a small fraction of the ones heading in our direction because the wobble will mean that only some of them hit us.
Right. So as usual for the Zooniverse projects, you got this kind of forum area. And looks like they're pretty active. This has been around for a while, I think.
Yeah, they just keep adding data, so it sticks around. It sticks around.
Even though it looks like there's a lot done, I think you've got a lot to work with still. And then the typical people collect images.
Oh, okay.
I think Cliff added one,
Cliff.
yeah.
If it keeps flashing.
Oh, no, you said that, I think.
Oh, yeah.
Yep, I thought I saw a new one. All right, so if you like to do this sort of thing, you can collect them as well, just like all the other ones. Oh, and this is a good place to see some variety of what are bursts, repeating, that kind of thing. And that's more like, I saw something more like this when we were kind of testing it out earlier this week. Yeah. But yeah, they probably just got a whole bunch of new material, and they're still sifting through it.
Mm-hmm.
All right. So let's see. I think that's going to cover that project pretty good. Kind of neat.
That does.
Well, let's see. I got to get there. Yeah. Here we go. Yeah. So that's kind of the project. If you want to check it out, absolutely give it a go. I think it's just sort of a fun kind of just keep at it and do it and help them out. And if you want to sign in, they're definitely asking you to see little things. You should sign in. Kind of cute.
Okay, some stellar events this week, February 17th through February 24th. It's a busy week again, and we missed Globe at Night last week. I wasn't here to keep you on track. Not that I set that one up, but so from February 12th through the 21st, in the southern hemisphere, look for Orion or Canis Major. In the northern hemisphere, look for Orion or Gemini.
And remember, this year they're going to give you options. Oh, we got a couple more comments. You ready?
Yep.
Okay. Let's see. Yeah, Cliff.
Like precession,
I think you mean.
Yeah. Yep. Of the Earth takes a long time to come around again. Yep.
Yes, it does.
Yep.
Oh, AC's got, should mention
peritons.
Yep. Or fake signals from microwave ovens at radio astronomy observatories. Okay. I should think they would ban that sort of thing. I don't know what a periton is, AC. Let us know.
Yeah. Basically, yeah, I guess if you're at an observatory, maybe you don't have those hot pockets.
Or you eat them cold. All right, so you want to continue on?
Okay, yeah. So,
I can't.
As I said, southern hemisphere is Orion or Canis Major, northern hemisphere is Orion or Gemini. The idea is to go out, take pictures, and report on their site. and you
can use your cell phone.
Yeah.
Yeah. It's actually a pretty nice program on the cell phone.
Yeah.
You want me to take over?
Let's see.
Okay.
February 17th, Pluto and the Moon are in conjunction.
You'll see.
You'll see the moon. February 18th, Mercury and the Moon are in conjunction. Yeah, you'll actually see both of those, unless you're where Cliff lives, because it's cloudy there.
Sorry, man.
February 19th, Saturn and the Moon are in conjunction. February 20th, it's a new moon. Best time to observe, unless it's cloudy. February 21st, Neptune and the Moon are in conjunction. Yeah, good set of binoculars or a decent or a halfway decent telescope. You might
I
be
don't know
able to
about
see
Neptune. That was Uranus. We decided that we could see with binoculars.
That's true.
Neptune, not sure yet.
Yeah, probably need a better.
If you know, let us know.
February 22nd, Venus and the Moon are in conjunction, and yes, you can definitely see those together. And Jupiter and the Moon are in conjunction. So by force,
that might be pretty cool.
Venus and Jupiter are in conjunction if they're both in conjunction with the Moon.
Yeah, right.
February 24th, Friday night show. We're doing another profile. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel.
Okay, you want to do the share
actually,
screen? Because there are
Cliff.
some. Oh, good, yeah.
Finally got a shot of Orion
Yay.
and the Seven Sisters one day only. We'll send you a picture later.
It's like on special. One day only.
Yeah.
Well, I'm really happy to hear that for you because you stopped by and stuff, right? All right. So we're going to, let's see. Add the stream. Share it. I did find some other things like this great Orion Dark Sky Festival. It's March 16th through 19th in Panamint Valley, California. That's actually not too far from us here. But I did just find out about it. So there you go. The design of spaceship for ESA is still going. It's almost due, though. You want to check that out by February 28th if you would like to submit an offering.
Do you have to be a member of the ESA or a European country?
You know what? I don't know that I determined that. They just calling on creative people. They want it to look very European somehow. That ought to be interesting. But I didn't really catch if it was Europeans only or if it was open to anyone in the world.
Well, they do have it being white, so that would help.
Okay. Next is Satellite 2023. That's March 13th through 16th in Washington, D.C. And there is an option to get a free pass for I think it's the exhibit hall. Oh, Cliff comes in with Orion is perfectly overhead here. Yay, very cool. All right. Oh, we got another one. Oh, wow. We only see these furries as amazing as much as the hype surrounding the first pulsar found. The universe keeps throwing up new stuff all the time, chuckling at our kid-like reactions. Oh, AC comes in with, had them scratching their hair for years until they figured out they occurred during lunch hour. Okay. And he's talking about the microwave and the, what'd you say? Peritons. I still don't know what that is. Help us out, AC. All right. So,
might be the name that they gave them, trying to figure out what the hell that was. But
okay, maybe, yes. Next up is space mobility. That's February 21st to 23rd. That's actually coming due soon. I remember Brooke was telling us about that for high school internship.
Yep.
All right. So, yeah, check it out if that is something that might work for you. What's the next one?
Google Doodle.
Oh, yeah, Google Doodle. This one's going to be due on March the 7th. So, and I think it's pretty much, for K through 12, that's kindergartners through 12th grade. Young people, I believe it is for, the United States and its territories. But that one's due on March the 7th.
Which pretty much cuts out half of our audience. But
yeah, sorry about that. I do try to find things for everybody. All right, so Next Generation Suborbital Researchers Conference. That is in Boulder, Broomfield, Colorado.
Okay.
All right, and that's produced by SWR, the Southwest Research Institute, held at the Omni Interlaken Hotel, Broomfield, Colorado, February 27th to March 1st. That's the end of this month. Oh, AC comes back with Periton is a mythical creature composed of different animals.
Yep.
Okay. Interesting.
body of an eagle, head of a deer,
Ah, okay.
and some other bits.
And remember, the nominated student was Perseverance. The 6th round closes on March the 1st. The awardees are announced March the 14th. They got a list over there a little bit farther. Yeah, here we go. So these are the key dates for nomination opportunities. And so far, the 6th opportunity is the last one on the list there. All right, what do we got? One more? Oh, and our friend JPL just today told me, hey, Europa, the Europa, what is he calling it?
Clipper.
It is Clipper. That's what I'm thinking. It's Clipper, but no, that doesn't sound right. They are assembling it in the high bay at JPL, which we have been to a number of times and recognized it right away. Now, you can see this live 24/7. Yeah. Currently, there's not anything going on because, of course, it's 9:30 p.m. at JPL tonight. So, yeah.
So, yeah, it's 9:30, JPL. It's not crunch time, so yeah, there's no one there.
It kind of is. He was saying they're running 2 shifts, but they're clearly done by now.
Yep.
All right,
and just for you guys, I'm gonna pop this link into the notes.
Oh, good. And they do have a participate link on the end there, and I looked at it. I forget what they said. Let's see.
Yeah, why don't you pull it back to us?
Oh, all right, yeah. Where are we? Here we are. There we are. Right.
Yep.
Oh, Cliff has maybe you could do a show on stuff your followers that they have taken. Tell me more, Cliff. I would be very happy to do that. I just need to know what that means exactly. All right, and Jeff is coming up with that. Link should be clickable in the chat for you, whether you're on YouTube or Facebook. All right, let's see what else we got. We will be watching for your comments. Here we go.
If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, February 24th. Another profile, Jeanette Picard and her husband, Gene. We first learned about Jeanette when we reviewed Brooke Edwards' blog. Brooke was our guest 5 weeks ago on January 20th, 2023. Jeanette was the first woman past the stratosphere in 1934.
Didn't know about her until
so
I saw Brooke's blog.
Yeah, so tune in next week as we go into more detail about Jeanette Picard.
And it's interesting, the names. We'll talk about that later too. Yes, I see. All right. Photos via telescope, etc.
Oh, so
I like that idea. Yeah, I like that idea very, very much, Cliff. And if we can accomplish that, let's do that. I know one of the problems we've had before is kind of bandwidth, getting you on, or maybe you can send us, kind of a slideshow thing and we can present it. You can comment on it while we're showing it, that kind of thing. I hope the lag isn't as bad as sometimes. It seems like we're doing a little bit better as far as how long it takes for us to speak, then you to hear, and then you to reply. But, practice for space travel. All right, anything else?
Nope, not from here.
That's it for the comments we've seen so far. Thank you so much, everyone. We really appreciate you, Cliff, and Dawn, and AC, and Dave, and Scott was here. I remember seeing Scott.
Yep.
And did we get them all?
Oh, no.
No, I remember we got more. I know. Let's see if I can say his name again correctly. There's Dawn. Abhishek Pandey.
Yep.
Hopefully that was it. Thank you so much for joining us. We really appreciate you being here. You make a big difference in our show. Thanks so much.
Okay.
Have a great week.
Yep. Bye-bye.